Hello, Gagan here, and in this video, we'll be looking at a simple Streamlit chatbot application that is built using LangChain and Pinecone as our vector database. So before we get started, let's look at all the required packages. So these are the packages that we'll be using. We'll be using Streamlit. We'll be using OpenAI embeddings to define our embedding model. We'll be using Pinecone. We'll be using Chat OpenAI from LangChain to define our LLM model. As you can see, I have defined the OpenAI key in my .env file. We'll import that. Once we have that, we can define our LLM model using this function, and we'll set the temperature to 0, and we'll be using 3.5 turbo as the LLM model. So once we have that, let's quickly look at how we can define a free index using Pinecone. So once you're logged into your Pinecone console, you can create one free tier index, and the most important number here is that the dimensions. So you can have the index of any name, but since we're using the OpenAI's embedding model, which supports 1536 number of dimensions, and we define the dimensions here. So you can use any embedding model of your choice, but make sure that you know the number of dimensions that embedding model supports. So once we have that, we have the cloud information here through GCP, and the environment is GCP starter, and the API key would be right under this API key section. So we can copy this from here, and we can define the index like this. So once we have our index set up, so these are a bunch of helper functions that we'll be using in our code to extract PDFs and to create embeddings, etc. I'll be going over each of these functions in the code. So let's quickly look at the main function. So we'll be prompting the user to upload his or her PDF. So once the user uploads the PDF, we'll be looking whether this PDF has already been converted to vectors and stored in our database or not. If it's already stored in our database, we'll simply point our retriever to that. Otherwise, we'll just create vectors from scratch. So as you can see, this has been processed function basically checks from this processed files.txt. So if it already exists, we'll just uh, point our retriever to that. This one, if it doesn't exist, we'll extract the pages using this helper function. Then we define our embedding model, that is the OpenAI's embedding model. Then we create our vector DB and call this embed and store helper function. What this does is basically it creates your vectors for that particular PDF and stores it in the index, and it returns this doc search object. Once we have that, we can define the state retriever to point to this vector DB now. And once that is done, since we have created the vectors, we'll just mark it as processed using this helper function. This basically what it does is it just writes the PDF name to this processed files.txt. So once that is done, if it is an existing PDF, we'll just use this pinecone from existing index and call this index name along with the embeddings. And we'll just say we'll be using the existing data. So once that is done, let's look at the conversation, how we can initiate conversation between the human and the bot, and how the user can ask questions. So once the user starts asking questions, and once the user hits enter, we can see this function is getting called, the handle enter function. So what happens here is it basically takes that user query or question into this, appends it to this chat history object. So this chat history keeps a track of the conversation between the user and the bot. So once we append this, now we need to figure out a way to answer that question. So for that, we'll be using LangChain's retrieval QA chain, and for this we'll pass the LLM, we'll pass the chain type as stuff, the retriever objects that are based on the setting that we did here, and then we'll whatever response that we get from this, we'll append it to the bot response in the chat history, and this is how the conversation continues. So as you can see, this will only pull out relevant chunks from the vector database, append it to the user's query as the context, and then it is given to the LLM model to answer. So the LLM has more context to answer the question based on the question here, based on the retrieved chunks here. So this is how the code looks like. Let's look at the application in action. So let's look at the index as well. We'll keep track of what's being stored in the index simultaneously. We see the initial vector count as 0. Let's upload a PDF. So this is an assignment that I had in the last semester. Let's upload this. So based on the size of your PDF, this is going to take a while. So it's going to process the PDF. So once the PDF has been processed, you can see that we can enter a question here. So let's say, what is a system? That should be a relevant question. So based on this PDF and the context that it extracted, it says a system is a collection of people, software, hardware, processes, and methods organized in a specific way to produce a product, service, or result. That is perfectly accurate. Let's look at another question. Let's say define risk. So this question, in context of this topic, should be risk is defined as a factor or event that, if it occurs, will have a negative impact on system. That is perfectly accurate. Now let's give it a question that is totally irrelevant. So let's just say define what? Define osmosis. Let's see. So for that, it says there is no information provided in the given context to answer this question. So that is perfectly accurate. So that's how this application works. Let's look at another scenario where we said if it's already existing in your database, and how do we process that. Now, if you go and check your index now, if you look at the index, it has already created this many number of vectors, and you can see 296 vectors have been created. And if you go and check the processed files.txt, we have already processed this uh, PDF here. So let's quickly run it again and see whether it creates new vectors or uses existing vectors. So let's run the application again. Now let me quickly upload the same PDF again. Again, this is going to take a while, but that was fast because it was already processed. So it says using existing data. So we just, if we ask what is the system again, it's going to give us the same answer. Perfect. So as you can see, it comes up with the same answer, and the vector count hasn't changed here because we're just pointing our application to the same vector again, to the same index again, rather than creating new vectors for this particular PDF. So that's how this application works. I'm going to drop the link to the code in the description for my GitHub, and that's it. Thank you.